Good morning to all. In the previous class, we are discussing about amino acid. So in these amino acids, so what is the classification of amino acid and how we can prepare the amino acids? So these are discussed in the previous class. But today, we are discussing about what is a peptide bond, how the peptide bond is formed. Look at this. So what is a peptide bond? That is, amino acid contain both the amino group and the carboxylic group. Peptide are the amides formed by the nitration between the amino and carboxylic group of two or more amino acids. Two amino acids can combine with each other by the elimination of water molecule to form a amide bond. So this reaction takes place between the carboxylic group of one amino acid and NH2 group of another amino acid. The amide bond is called peptide bond, or it is called as peptide linkage. Okay. What is a peptide? What is peptide? How the peptide is prepared? To formation of a peptide bond, we can take the two amino acid. In these two amino acid, one amino acid carboxylic acid group and another amino acid amine group. They both are combined and they release the water molecule and produce a amide bond. So that amide bond is called as peptide bond or peptide linkage. The next one is the two amino acids are combined by the loss of water molecule and produce a peptide bond. Take this, the next slide is so here we can take, in this reaction, we can take the two amino acids, one amino acid toward the left, one amino acid toward the right side. So in this one amino acid carboxylic acid group, so here, so this is the amino acid. In this one amino acid carboxylic group is combined with the another amino acid amine group. So in this, the amino acid, 1 minute. So here, in this reaction, this amino acid OH, it is combined with the another amino acid amino group's hydrogen and eliminate the water molecule. And it produces C double bond O NH. C double bond O NH. So this is called as amide. So the formation of amide is called as peptide bond. Okay. Then the combination of 3, 4 or many number of amino acids to form tri, tetra or polypeptides. A polypeptide is formed by combining less than 1000 molecules of amino acid. Okay. How a polypeptide is formed? The 1000 molecules of amino acid combined and it is converted to polypeptide. Then the next one is, in peptide, the amino acid contain free amino group. It is called as N-terminal. It is always written as the left-hand side. Look at this. So in this example, here this is called as peptide. Okay. So in this peptide group, the NH2 should be right toward the left side. So that's why it is called as N-terminal group. And the CO2H group is written toward the right side. So that's why it is called as C-terminal group. Okay. The amino acid contain free carboxylic acid group is called as C-terminal amino acid and right on right side of the chain. Okay. So here the NH2 is toward the left side. It is called as N-terminal. The carboxylic acid group is toward the right side. It is called as C-terminal. Okay. Then the peptides are named by listening the amino acid present in order. They started from N-terminal amino acid. In that, N is replaced by NYL. Okay. So here you can take this example. This is the example. In this example, this is N-terminal. It is N-terminal. It is N-terminal. It is the C-terminal. Okay. So here its name is glycinyl alanine. Okay. So here this peptide bond is formed by the combination of glycine as well as alanine. Look at this. So here this is the structure of glycine. This one is glycine and this one is alanine. We can write glycine, alanine. Okay. So here this ion should be eliminated and it should be written as glycine is called as glycinyl. NYL prefix should be added to the peptide form. So this is the naming process. Then move to next slide. So here how we can synthesize a peptide. It is called as synthesis of peptide. Look at this. In this synthesis, peptides are synthesized by the following steps. For example, we can prepare the different types of peptide bonds. So the amino group of amino acid, the amino group of amino acid is protected by carbobenzyl oxychloride. The protected amino acid is converted to a acid chloride by reacting with the thionyl chloride. Acid chloride is reacted with another amino acid or peptide linkage. The compound undergoes hydrolysis reduction to form a peptides. Look at this example. So here in this example, we can take the benzoxide chloride. So this is the structure of benzoxide chloride. It is reacted with the amino acid. Then this amino acid, the amino group hydrogen and the benzyl oxychloride, chlorine is eliminated as HCl and a sigma bond is formed in between the C double bond O carbon as well as NH. So this type of structure is produced. This is the structure. Okay. Next, it is reacted with another mole of amino acid in the presence of the thionyl chloride SOCl2, HCl is eliminated. Double bond O group is linked with the NH group. Okay. Then this type of structure is produced. This structure, it is involved in the reduction process. It is converted to peptide. So this is next one is so this is the another preparation method of the peptide bond, that is glycinyl alanine valine. So by the combination of these three amino acids, so this type of structure should be produced. The next is about the proteins. So which are called as proteins and what is the classification of proteins? So the proteins are polymers of amino acid. So the proteins are the polymers of alpha amino acid, a bond by the peptide linkage. So this molecular weight is more than the 10,000. These are formed by the condensation of more than 100 molecules of alpha amino acids. They produced in all living cells, for example, skin, nail, hair, etc. Okay, once I repeat. So which are called as proteins. The proteins are the polymers of alpha amino acid. Okay. The polymers of alpha amino acids are called as proteins and its molecular weight is more than the 10,000 and these are formed by the condensation process by the 100 molecules of alpha amino acids. These are produced in all the living cells like skin, hair, nail, etc. Then what is the classification of amino acids? So these amino acids are classified into various types. Okay. Based upon the structure and based upon the function. So these proteins are two types. Based upon the structure and based upon the function, amino acids are two types. Number one is fibrous proteins. Number two is globular proteins. So which are called as fibrous proteins? So these proteins are linear and thread-like molecules which tend to lie side by side to form a fiber. Okay. So these fibrous proteins are the linear proteins and they have the thread-like structure. Okay. And these are insoluble in water and the polypeptide chains are held together by intermolecular hydrogen bond. So, the polypeptide chains are held together by intramolecular hydrogen bond ద్వారా formation అవుతున్నాయి. These are used for the connection, support and structure in living organisms. Okay. So which are called as fibrous protein. So the fibrous proteins are having the linear and thread-like molecules. The fibrous proteins are linear and thread-like molecules. And they are by the side by side, they are living and it become as a fiber-like structure. And these are insoluble in water and the polypeptide chains are held together by intramolecular hydrogen bond. They are used for the connection, support and structure in living organism. The example is keratin. So keratin is the fibrous protein. So it is present in the skin, hair and nail. Okay. Myosin. This myosin also one of the protein. It is present in the muscles. The next slide is look at this. The next one is globular proteins. So which are called as globular proteins. The polypeptide molecules are folded in spherical shape. Okay. The polypeptide molecules are folded in spherical shape, in spheroidal shape. Okay. So these are held by intramolecular hydrogen bond, easily soluble in water. These proteins regulate life process. Okay, which are called as globular proteins. Globular proteins. These are by the polypeptide molecules are folded. Then they are the polypeptide molecules are folded in a spherical shape. Those are called as globular proteins. So these globular proteins are produced by the intramolecular hydrogen bond. And these are easily soluble in water. And these proteins are regulate the life process. For example, enzymes, hormones, hemoglobin. Okay. So these are the examples of globular proteins. The next is classification is based on hydrolysis of proteins. Based on hydrolysis, it is three types: simple proteins, conjugative proteins, derived proteins, which are called as simple proteins. So these are the proteins which on hydrolysis give alpha amino acids. Okay. So which are called as simple proteins? The proteins which are involved in the hydrolysis and produce alpha amino acid, those are called as simple proteins. Example is albumin and globulin. The second one is conjugative protein. proteins, which are called as conjugative proteins. So these are the proteins of a peptide bond is a mixed with non-protein part. It is called as prosthetic group. That groups are carbohydrates, phosphates, lipids, etc. So conjugative in this a meaning is present. It is the proteins is produced by the conjugation process. It is linked with the different types. That means so here the peptide bonds are linked with the prosthetic group. Then prosthetic groups are like carbohydrate or phosphate, etc. So those are called as conjugative proteins. Next is derived proteins. These are produced by the metabolic degradation of simple and conjugative protein. So how the derived proteins are produced? The derived proteins are produced by the degradation of simple and conjugative proteins in the metabolism. Example is peptones. Okay. Then structure of proteins. So what is the structure of proteins? Elemental analysis and molecular mass explain the protein structure is derived into different types that are primary structure, secondary structure, tertiary structure. So what is a primary structure? The covalent structure of a protein is called primary structure. Okay. The covalent structure of a protein is called as primary structure, and the protein molecules are joined to one another through the covalent bond to form a linear chain. All the proteins are hydrolysis give alpha amino acids. So these structures of proteins refers to the same of amino acids. So which are called as primary, which is called as primary structure? Primary structure is nothing but they are produced by the covalent structure. The covalent structure of protein is called as primary structure. Okay, in this the protein molecules are joined to one to another through the covalent bond and produce a linear structure. So these are called as primary proteins. The next one is secondary structure. Okay, the secondary structure of protein is related to a range of polypeptide chains in a linear or maybe folded to form a helical structure. Okay, so it is having the secondary structure is having the helical structure because these are arranged with the polypeptide chains. The helicals present on right side is alpha helix. Okay, the hydrogen bonds formed between the amide hydrogen of one peptide and carbonyl group of another peptide. Alpha helix is a spherical structure. So this alpha helix is having the spherical structure and it is formed by the folding of polypeptide chain through the hydrogen bonds. The beta helix structure is formed by side-by-side arrangement of the different polypeptides through the intramolecular hydrogen bond surrounding in a chain. The next one is tertiary structure. So what is the tertiary structure of this proteins? So here it is a three-dimensional shape of protein produces from folding of polypeptide and a complex structure. Look at this. So this structure, it is called as a tertiary structure of proteins. Okay. So it is like a three-dimensional shape. Okay. So up to this, the amino acids, the topic should be completed. So in this amino acids, we are discussing about which one, what is amino acid, and what is the classification of amino acid, and how we can prepare the amino acid. Generally, we can made by two process amino acid. One is from the carboxylic acid method, Strecker synthesis, and malonic ester synthesis. Then we are discussing about physical properties. So in this, we are discussing about the what is its Witter ion and its properties and isoelectric point. So these are the important questions. These two. Then the chemical properties, we are discussing about the according to carboxylic acid group chemical properties and according to the amino group chemical properties. Then next we are discussing about the proteins. Okay, so in this next is about peptides. So how a peptide bond is produced and how we can synthesize a peptide bond. The next is about proteins. In this proteins classification, so the classification is mainly based upon the structure and function. It is two fibrous proteins and the globular proteins. And based upon the hydrolysis, it is three types. One is simple proteins. Number two is conjugative proteins. Number three is derived proteins. Okay. Then based upon the structure of proteins, it is different three types: primary structure, secondary structure, and tertiary structure. So up to this, the amino acid chapter is completed. Then move to the inorganic topic. Let's wait 1 minute. So today we are discussing the next topic, that is the inorganic topic. In this, we are discussing about the coordination compounds too. So how a coordinate covalent bond is produced, how many types of ligands are present, what is the composition of how we can produce a metal complexes, as well as what are the factors effect of the what is stability of the complex and what are the factors effect, as well as we are discussing about the slope ratio method as well as jobs method and applications of chemical analysis. So these terms we are discussed in this class. Let us take the introduction. The transition metal ions metal complexes with chemical species. The capable of donating lone pair of electrons. These complexes are formed through the coordinate covalent compound. The metal ion in this process behave as a Lewis acid and chemical species bond to the metal ion function as Lewis pairings. For example, silver plus copper plus 2, nickel plus 2 form with ammonia as the complex as AgNH3 taken twice. It is called as diamino silver 1 complex. Then the next complex is tetraamino copper 2 complex. Then the another complex is tetraamino nickel 2 complex. The next is, look at this. Here, this is the silver metal. This is the silver metal. It is bonded with the 2NH3. So that's why the structure should be Ag NH3 taken twice. So this is the complex. Then the next complex is CuNH3 taken 4 times. The next complex is NiNH3 taken 4 times. So here in this coordination complex, the metal ion always having the positive charge and the ligand is having the negative charge. Okay, so this negative charge ligand donate the pair of electrons to metal atom and produce a coordinate covalent bond. Coordinate covalent bond. Okay, this type of complexes are called as coordination complexes. So here in these complexes, only the transition metal atoms, that means the D block elements, are involved in the formation of complexes. Not all the atoms are not acting as the all another elements are not produce the coordinate complexes. Only the D block elements produce the complexes. That is the transition metals. Why? What is the reason? Because the D orbitals are having the small in size and they are having empty, okay, vacant D orbitals. So due to these vacant d orbitals, this metal atom require it having the positive charge and it is having the higher oxidation state. So due to that reason, it is having the vacant d orbital. So these vacant d orbitals are ready to accept the electrons from the ligand because the ligand it is having the pairs of electrons. So these pairs of electrons are ready to donate these electrons to metal atom and produce a coordinate covalent bond. So due to that reason, so this is the metal atom and this is the ligand. So the ligand donate the electrons to metal atom and produce a coordinate covalent bond. Here the metal atom is having the positive charge and the ligand is having the negative charge. And in this metal atom is called as acceptor and the ligand is called as donor. Okay. And produce a coordinate covalent bond. So the different types of ligands are present generally based upon the nature. So in this your syllabus, they give us few lines only. So that's why I extend few topics. So here, in this your syllabus, you having the 3 types of ligands. So one is based upon the nature. Based upon the nature, ligands are 2 types. Number 1 is negative ligands. Negative ligands are nothing but the ligands which are having the negative charge. For example, cyanoligand. So this cyanide, it is having the negative charge. So that's why it is called as negative ligand. Chlorine, it is having the negative charge. Bromine, it is having the negative charge. Vice versa, OH, it is also having the negative charge. Okay. Generally, this Cn minus we can take. Cn minus is called as cyanide. When we are right, it is as a ligand, this "ide" suffix should be eliminated and O suffix is added. So cyanide is converted to cyano, then only it is called as a ligand. Okay. So if the ligand, it is having the negative charge, it is called as negative ligand. The next is about neutral ligand. Let is positive ligands. Let we take positive ligands. So the ligand which is having the positive charge, H3O plus, it is called as hydronium. NH4 plus, ammonium. Okay. So the ligands which are possess the positive charge, it is called as a positive ligand. The next is about the neutral ligand. Already in the term, we have the name neutral. That means it doesn't having the negative charge nor the positive charge. That type of ligands are called as neutral ligand. For example, NH3 is there. This NH3, it is having the pair of electrons, but it doesn't acquire the positive charge or negative charge. So, this type of ligand is called as neutral ligand. Its name is amino. Okay. Then here H2O. In this H2O, the oxygen atom is having the two pairs of electrons, but it doesn't having the any charge. So that's why this H2O is called as aquoligand. Okay. Then next is about, we can take the another ligand, that is ethylene diamine. So this is the structure of H2N CH. Wait a minute. H2N CH2 CH2 NH2. So this is the structure of ethylene diamine. So it is the ethylene, these two are the amine. So it is called as ethylene diamine. So here this nitrogen atom is having the pair of electron. This nitrogen atom also having the pair of electron. But it doesn't having the positive charge or negative charge. So that's why it is called as, it is also example for neutral ligand. Okay, this is the class, just normal classification based upon the charges. Okay. Then the next one is formation of metal complexes. How a metal complex is produced. The formation of metal complexes depend on the condition of the experiment. Some complexes are formed readily in acidic solution and some in alkaline solution. The oxidation state of the metal ion to some extent favor or disfavor of formation of metal complexes. That is, here we can take, this is the metal atom. It possesses some of the charge. Okay. It is having the various oxidation state and it is reacted with n number of ligands and it produces a complex like MLN. So this is the formation of complex. So this complex is produced in the presence of the acidic solution or in the presence of the alkaline solution. Okay. The oxidation state having the metal atom, it is reacted with n number of ligands and produce a complex. So that is the formation of the complex. Next, you can take this example. So here the example is there, that is copper plus 2. Copper plus 2. It is reacted with 4 moles of ammonia. Then it produces a complex of CuNH3 taken 4 times plus 2. Okay. So this copper plus 2, copper in the plus 2 oxidation state, it is called as M plus N. Plus N is nothing but the various oxidation state. So here M is metal atom. The metal atom is copper. It is having the plus 2 oxidation state. It is reacted with 4 moles of ligand. So it is written as NL. N is equals number of ligand. L is equal the ligand. So 4 moles of ammonia, then it is converted to this type of complex. So this is the formation of a complex. In this, another example is there. The silver Ag plus, it is reacted with 2 moles of ammonia and produce a silver ammonia complex. The copper plus 2 also reacted with 4 moles of cyanide or cyanoligand. It produces tetracyanocuprate complex. The next one is iron plus 2, Fe plus 2. It is reacted with 6 moles of cyanoligand and it produces a complex of FeCN6 minus 3. It is called as hexacyanoferrate 3 ion complex. Okay. So this is the formation of complex. Next one is composition of metal complex. What is the composition in a metal complexes? The empirical formula of a metal complex is generally referred to on the composition of the metal complex. So empirical formula. So this after formation a complex is produced. Okay. So this is the empirical formula. So this empirical So this empirical formula, it is depending upon the formation of the complex or composition of the metal and ligand. This is generally represented as metal ion ligand ratio of molar concentration. Okay. So the formation of the complex or the empirical formula, it is depending upon the molar concentration of the ligand as well as the metal. Thus, the composition of metal complex is generally represented as the ratios are 1:1 ratio or 1:2 or 1:3. So the 1 is always the metal and 1, 2, 3 are it is called as ligand. So 1:1 is nothing but the metal and ligand is in the same ratio. 1:2 is that is 1 is the ratio of metal and 2 is the ratio of ligand. 1:3 is 1 is the ratio of metal and 3 is the ratio of ligand. Okay. So this composition is determined by different methods. Generally, the colorimetric or spectrophotometric methods are employed for the colored complexes. Okay. So based upon the colorimetry analysis, we can determine the empirical formula of the complexes based upon the colors. Okay. So here the two process we can use to determine. One is slope ratio method. Second one is Jobs variation method. Okay. By using these methods, we can find out the empirical formula or find out the concentration of the metal and ligand ratios. The spectroscopic determination of the composition involves different stages as listed below. They are establishing of complex formation, fixing up of optimum condition for the formation of stable complex, ascertaining the character wavelength for determining of the composition, the method of determining the composition. So based upon these factors, we can determine the spectrophotometric method. The first one is establishing of complex formation. How we can establish the complex? To know to a known value, that means suppose we can take 5 ml of the metal ion solution, a known excess of ligand solution is added under a different pH condition. That means suppose we can take the 5 ml of metal. To this we can add the 100 ml of ligand solution and it is taken in the different pH values. Okay. The pH at which appearance of a dense color different from that of the metal ion or the ligand solution suggests the formation of a complex at the pH. So this fact is confirmed or established spectrophotometrically. The absorption spectra of the following solutions are recorded in the visible wavelength region, that is 400 to 800 nanometers. Okay, so here in this we can take the 5 ml of the metal solution and 100 ml of the ligand solution. And we can take this solution in the different pH values. At the different pH values, each pH value we can kept the solution into the spectrophotometer. Then we can observe the different values. Okay, by these values we can find out. So which is the constant pH value, which is the not constant pH value. And this spectrophotometry, so that the light should be observed at the region of 480 to 800 nanometers. Here we can take the different solutions like metal ion solution, ligand solution, and metal ion plus ligand solution. So based upon these, we can take it in the spectrophotometry. First, we can take the metal ion solution and it is kept into the spectrophotometer and record the data. Then take the ligand solution in different pHs and it is recorded in the spectrophotometer. Then mix. We can take the different ratios, that is 1:1, 1:2, 1:3 of the metal and ligand solution, and it is kept into the spectrophotometer and record the values. Okay, by using this we can find out the which concentration at which pH we can get a specific complex. Okay, so this is the method. Then in the next class, we are discussing about the determination of composition of the metal complexes by using the two methods. The slope ratio method and second one is the Jobs continuous variation method. The next topic is the stability of the complexes as well as the factors affecting and uses of the coordination compounds. So these topics we are discussing in the next class. Okay, thank you.